Good morning. This is for become both SEM. We are starting our continuing our compound interest class once again. Now, if the difference between simple interest and compound interest is rupees 200 at 4% for 2 years on certain principle, then find the principal. We suppose that the principal is equal to rupees 100. Now, since we have taken rupees 100 because since the nature of the problem is such that the difference between the two interests is something we cannot take it as x, because if we take it as x, then we will not be able to get the result. So we are taking an arbitrary figure, that is rupees 100, which is the minimum amount. So now SI, if a simple interest for 2 years, R into P into N by 100, or we have R, since we have taken the principal as 100, we have 100 into 4 into 2 by 100, that is equal to rupees um, uh, 8, and that the compound interest as for 2 years as equal to P into 1 plus R by 100 whole to the power n minus 1. This is the compound interest as we had seen from our previous n days class. Now the compound interest is equal to 100 into 1 plus 4 by 100 whole square minus 1, that is equal to 100 into 1.04 whole square minus 1, and the 1.04 whole square is 1.0816 minus 1, only 100 into 100 into 0.0816 or 8.16. Now, as we know that when we are calculating simple interest and compound interest for any principal which is more than a year, now the amount will always be more for case of compound interest. So in case of the difference, so we are taking the difference between the two as difference between the compound interest and difference between the simple interest. So difference between the compound interest we are taking as 8.16 minus 8 is equal to 0.16. So if the difference is 0.16, difference between the compound interest and the simple interest. Now, as we see in the problem statement, the difference between the two interests, that is simple and compound, is the rupees 200. So when the difference is 0.16, then the difference is 100. So when the difference is when difference is the interest is 0.16 and the principal is 100. So when the interest is 200, what will be the difference? So 2 into 200 divided by 0.16 into 100. It will be 1,25,000. But I'll explain this. Say the difference between two interests is 0.16 for rupees 100. So for rupees 1, the amount will be 100 divided by 0.16. So for rupees 200, it will be 100 divided by 0.16 into 200 as has been done over here. Now we can also see a certain principal doubled in 6 years. What is the rate of compound interest? Now we have the principal is equal to P and the amount after 6 years is equal to 2P. Now the principal has doubled itself in 2 years. So it is double the amount, or it is two. Now we have the amount A as equal to P into 1 plus R by 100. We have 2P is equal to P into 1 plus R by 100 whole to the power 6. That is principal doubled in 6 years. Therefore, 2 is equal to 1 plus R by 100 whole to the power 6. Now, there is a certain dilemma over here as to whether we use the log table or whether we use the simple calculated portion to simple calculator and we use the interpolation method to solve this problem. I have chosen the simple interpolation method instead of the log method because log table may not be available for all of you. So 2 to the power n is equal to 2 to the power 2 is equal to 1 plus r by 100 to the power of 6. So 2 to the power 1 by 6 is equal to 1 plus r by 100, assuming both these sides numerators are equal. So we have 1.1227, that is the both the powers are of uh, powers with rate to 2 each. So powers of 2 each, and that means 1.42 to the power of 1 by 6 is 1.1227. 1 divided by 6 would be says 0 point something. Uh, and it comes up to 1.2227, or is equal to 1 plus r by 100, or 0.1227 is equal to r by 100. So we have r is equal to 12.27%. Now it will differ about 12.3%. If you use log tables also, we'll get around 12.3% plus minus a certain amount due to the calculation variations of the decimals and the rounding figures, and so on. Now, what sum will be available for rupees 21,490 in 5 years at 12% compound interest payable half year? Now, here also, like previously, we have to use the interpolation formula like this to calculate the amount. Now, because we like to differ at the like to differ in using the log table. Now, what we have the principal P as 21,490. Now the amount of years, that is R, is equal to the number of years N is equal to 5, and the rate of interest R is equal to 12%. However, there is a small twist in this problem, in that the interest is payable half yearly. So if we have the principal as a P, and A is equal to 21,490, N is equal to 5, R is equal to 12, and K is equal to 12. We have using the formula that we have previously used, but with a small twist. So previously we had the formula as A is equal to P into 1 plus R by 100. Now, however, as we are paying the interest half yearly, we are paying interest for 5 years. So how much interest are we? How many times are we paying the interest? That is 5 into 2, or 10 times. Now, since we have A is equal to P into 1 plus R by 100K into n into k, or 21,490 is equal to p into 1 plus 12 by 100 into 2, or 100 into 2, because we have to divide the rate of interest also, because if it is 12% for a complete year, then it will be 12 by k, or in this case of 12 by 2 for the half year rate of interest, and the number of times the interest paid will be multiplied. That is, for years it would have been to the power of n would have been 5, but for half yearly it will be 5 into 2, 10 times. So 21,490 is equal to p into 1.06 to the power of 10. Now I have removed all the calculations. As previously, we calculate the value of 1.06 to the power of 10 and divide that by divide 21,440 by the amount. You will get a figure equal to 12, in or equal to 12,000. Now, if you are using logs, the amount might differ, but since it is better to use your calculator for this purpose, I would prefer using 1.06 to the power of 10 and then dividing that amount to get this figure. If you get the figure around 21,400 and around 21,490, you are very well and very well correct. So in this ends the session for compound interest. I'll be sending you the problems in the group later on, in the group mail ID later on.